Welcome, everybody. Thank you again for showing up today to our training on CPM scheduling for construction professionals. I'm going to give it a couple minutes for everybody to join. We've got a lot of people signed up, but this is part 2 of a 4-part series. We started the first part last week, and that was basics of CPM scheduling. Just want to make sure that everybody can hear me and see my screen. Please let me know via the chat box that I can be heard and you can see the screen. Awesome. Looks like I can. All right, we'll give it another minute or two and we'll get started. All right, we got a little bit of ground to cover today. I think there's about 36 slides to get through, and I'm a talker, so I'm going to get started. Who am I? My name is Michael Pink. I'm the founder and CEO of SmartPM Technologies. Prior to founding this company, I worked as a schedule consultant, delay analyst, project controls professional. What else? Process improvement guy for the construction industry. Worked at various consulting firms for my entire career. I've also gotten certified in planning and scheduling and cost engineering. I was an industrial engineer, which is a process improvement, optimization, and efficiency major from Georgia Tech. I've got my MBA. And SmartPM Technologies is basically the culmination of all the years of training that I did. Saw an opportunity to build a technology that would ultimately analyze a lot of the scheduled data in effective ways, with the idea that, having come from that forensic delay analysis world, I was kind of shocked that so many projects would end up late and over budget and in court. And that's where we founded SmartPM, is to create technology to help assist keeping projects on track, on budget, and out of court. So that is what we've been focused on. We've got a really great technology. We also have a lot of educational things that we do, which is part of what we're doing today. Teaching people in the industry how to understand CPM scheduling, to me, is one of the most important things we can do. There's schedulers, and then there's PMs and supers. I think and there's even executives out there. There's owner side, there's insurance companies. I think all of them need to understand this CPM scheduling process. I believe in the CPM scheduling process. It's just, quite frankly, misunderstood by most. So I appreciate you all joining us today. I hope you can learn a thing or two today. And what we'll be talking about in part 2, we talked about last week the basics, like what is CPM scheduling, how does it work, why does it work, what is this thing all about? I think we had a great meeting last week, and this week we're going on to the next level, and that's how do you build a high quality baseline schedule? Now, I'm not going to teach you how to use Primavera, and I'm not going to teach you how to use Microsoft Project. Those programs are, they are pretty much the most common CPM scheduling tools out there. I'm going to teach you what constitutes, when you do create a schedule, what are the best practices, what are the necessary steps to get from a concept in your head of a building all the way to getting it into a scheduling system, and then building out a schedule that's worthy of managing a job. There's some metrics that we can look at. There's some tests we can do. There's a process that we can follow to get there. This is probably going to start to go from beginner to intermediate. In the beginning, we'll be talking about some more basic concepts. Some of you probably already know these concepts. Hopefully, once you get the recording, you can maybe share it with some people in your firm that might benefit from learning these concepts, but towards the end of the discussion, we're going to start getting into best practices on the structural integrity of a schedule. And I think that that gets us out of, beginner mode and into intermediate mode. And then as we move forward into part 3 and 4, we'll be getting from intermediate mode to advanced mode. So this course is designed for everybody. Some things obviously are already known by a lot of you out there, but it doesn't hurt to, get different perspectives, brush up on things you already know, and also, follow through with getting to the more advanced things as we go. So today, developing a high quality baseline. What are we going to do? First thing I'm going to do is go back on some concepts we talked about last week that were very important about CPM scheduling. Just want to brush up on those. Now we're going to talk about how to set up a baseline schedule. Like, what is the process for getting from, knowing that you need to build something, having an understanding of how you're going to build it, and then going through a process of setting up a schedule that's going to be worthy of managing that job and trustworthy, actually, and accurate and effective. Believe it or not, there is a process. We've looked at many schedules here. I'd say about 80+% aren't actually fully following best practices, and there's a problem there. If you don't have best practices built into your schedule, you ultimately are at risk of not having an accurate critical path, and not knowing which activities are driving the end date of the job, which ones are high priority for resource constraints and all that sort of stuff. And if you don't know that and you're following it as if the schedule is telling you is gospel, then you're most likely following something that's going to mislead you, and then that ends up in that place that we talked about where you're late, you're over budget, and potentially headed to court. And we don't like that. We don't want to be there. We want to help you stay out of there. I want to talk a little bit about hard logic and crew logic. There's a lot of the, having studied a lot of the schedules, I realized that a lot of people miss crew logic, and that's a big problem. Bigger problem than I ever thought it was until we started studying, schedules en masse. Then I'm going to talk about, the DCMA methodology and a 14-point check that exists out there. There's, several tools out there that will check for things like missing logic and too many durations, or, too many lags, too many leads. And I'm going to talk a little bit about those concepts and tell you what those thresholds are really all about, why they're risks, and really come up with a model that we've been deploying successfully with our customers that ultimately gives you an understanding of where you stand on that quality spectrum and where you want to be. It's important, obviously, again, because it will result in a better, more accurate critical path and a better, more trustworthy schedule. I want to show you some of those examples and give you a couple parting thoughts, summarized version of this entire PowerPoint, and then we'll get into what we're going to be talking about next week. So let's go. So again, first and foremost, for all the people out there that were there last week or maybe not, scheduling, CPM scheduling is a pretty simple process. It's been kind of misunderstood. A lot of people think it's a lot more difficult. They call it the dark arts in construction. But the reality is a schedule consists of all the necessary tasks to complete a construction project. So taking what's in your head of all the things that need to get done to get from the moment of notice to proceed, or even before that from the design perspective, to ultimately having turnover or substantial completion of a project to a point where all the payment applications are done and the it's there in its whole. So you got to think about that. And then for each one of those tasks, you've got to assign a duration, like how long is it going to take to do this thing, this one part of all parts of this overall project. Then you got to think through, well, how are these activities related? What's the sequence, and how does one activity drive the ability to start another activity for every single activity? Once you have all that information, that's really what the user enters. All that's superimposed by the computer program, the CPM scheduling engine, to create a schedule. And then it does one more thing that we talked a lot about last week, is it creates a calculation called float or slack. And that's essentially a read of a prioritization based on the sensitivity of that activity delaying the project end date. That's what critical path is all about. It's the longest path between today and the end date of a job, such that any Any activity on that path, if delayed, will delay the end date of the job, and every activity has a slack or float value associated with it. And the higher that number, the more days or more room for delay that activity has. And if it's the lower the number, the more sensitive it is to delaying the job. Those become our highly critical, most high priority activities are the ones with the lower float. Near critical is generally deemed between 10 or less days, and I view those as highly critical as well because they are high priority. 10 days can go pretty quick in construction. So anyway, that's how it works. I want to remind you of the most important rule, is that all logic needs to be accurate. All durations need to be estimated right, close. And then the best practices are deployed into the scheduling program. This essentially requires almost near perfection in a schedule if you want to get the benefit of that program. That's what the industry has struggled with, is if you're missing logic, or if you forget to do a few things in terms of crew logic, or if you put in some long duration activities and not enough detail, these things can result in a critical path that starts to tell you things that you need to be focused on, and they just aren't necessary, and they're not accurate, and then you end up not focusing on the true areas that would ultimately manage to that end date effectively. So we're going to teach you today the best practices. You are in luck. We're going to teach you how to build a high quality baseline schedule. So first of all, I want to explain what is quality. A lot of times I've talked to people in the past and they've mentioned that they think quality means that the durations are right, and that's it. That they've thought through and it looks good. Yeah, it looks good on paper. It looks like they're flowing in order and it looks like those durations are right, but that's not quality. You can have a poor quality schedule that looks beautiful and looks completely accurate. The flow looks amazing. And it's just not right. It's not helpful. That all gets back to that critical path thing we were just talking about. So number one, we need to make sure there's sufficient detail. In the rules of CPM scheduling, different people have different opinions, but when it comes to the construction activities, the general rule of thumb is don't have any activity over a month long. If you think about an activity of a thing that you're going to be doing for an entire month, it can be pretty broad, and looking at that activity and being able to understand that activity or status that activity that's for a month long of work is pretty difficult order to just look at and understand and estimate the percent complete. So, actually the DCMA says more than 2 months, which I think is excessive, but I think most of the people I've talked to, most of the customers we work with, we guide them to wanting to keep most construction activities between 5 and 20 days, which is 1 week and 4 weeks. And procurement activities and that sort of thing can be a little bit longer, but we'll get into that in a little bit. All necessary logic. Rule number one is no activity should not have a predecessor and a successor except for 2 activities. That would be the first activity in the schedule because nothing's driving it, and the last activity in the schedule because nothing comes after it. Those should be the only 2 activities in the schedule that do not have a predecessor or a successor. When they don't, that's called missing logic. And second to that, crew logic. There's the logic in which you can build things, and then there's the order in which you want to move the crews around. Both of those need to be present, and we'll talk a little bit about that too. The other thing I say is fairly accurate durations, meaning close enough. A lot of people can overthink this. A lot of people use over-optimism bias when coming up with durations, which is what we talked about last week. I think tested durations are better than best case scenario durations. A lot of people, humans in general, are wired to think best case scenario when we do anything. And there we start inserting these, durations that we think are achievable at best instead of easily achievable with some risk embedded within. So I say fairly accurate durations. Like if you think about a construction job and you're putting up multiple floors, every floor can have a little bit of a difference in terms of what that duration will be for that trade. It's never going to be exact. It's going to be close enough. So you come up with like that average case scenario, and that to me begins to create a schedule that's trustable. So I would say don't overthink the durations. Definitely make sure that you risk adjust a little bit. Don't think about, we can get it done in 5 days if everything goes perfect. So we're going to say it's 5 days. We're going to maybe say it's 7 days because there could be an RFI or it might rain. Those kinds of things you got to think through. And again, the whole reason is if these things aren't all done and orchestrated properly, we're defeating the whole purpose of the program and pretty much the most powerful features of the program, and that's giving us that prioritization plan through those float values. So first, I want to talk a little bit about something that I hear a lot. There's planning versus scheduling. I go to the CPM scheduling conference, and I think there's debates over, are you a planner or are you a scheduler? To me, planning is somebody that really thinks through the schedule, not just a person that can use a scheduling program, which some people out there, that's what they do. They don't understand how to build an actual project, which means they have to work with the PMs and the supers. PMs and the supers and other members of the team that know how to build are instrumental in building a good schedule, but sometimes there's a disconnect between the two. A scheduler may not actually understand how to build something, but they know how to utilize a scheduling program, and a planner knows how to do both. And actually, a planner might not know how to use the scheduling program, but they know how to plan a job. So you need to have both of that involved. And there's a process here. You don't just jump into the schedule and start building it. You've got to plan. You've got to look at those drawings. You've got to think about that job. You've got to understand it thoroughly. You've got to map it out in your head. Think about the sequences and think about the organizational structures and that sort of thing. And then you got to bring that to life through the scheduling program. So once you sort of conceptualize a number of things, which we'll talk about, we can then get into scheduling. And then once that, you're not done at that point. You're not just going to punch it all in there and say, here you go, I'm done, because the first pass of any schedule is usually off. Let's just admit that. Probably the second and third path is potentially still have problems. This is one of those things that's complex. You can't just do your work and then submit it. You've got to double and triple check. You've got to make sure that it's in alignment with the contract. You've got to make sure that these durations that came out and the critical paths seem to hold water and align with what you were thinking. So you've got to always double check these things. You've got to make sure all the logic's there. You've got to make sure that this thing is passing that gut check as well. So that's where we talk about optimization is tweaking, really. So you don't get to that point where you can submit a baseline schedule till you do those three things. So we'll talk about those steps. Step one is very simple. You got to pick a CPM scheduling tool if you're going to build a CPM schedule. I've heard people use Microsoft Visio or Excel or even draw it out on a sheet of paper and think it's a CPM schedule. It's not. Those tools are not CPM scheduling engines. They're drawing tools. Of course, you can try to do some manual math to highlight what you believe to be the critical path at any given point in time, and you can use them to update and recalculate completion dates and finish dates and all that. But that's a lot of work if you want to do it effectively. So you got to pick a program that's actually called a CPM scheduling program. There's Primavera's Oracle and Microsoft Project are the most common. There's also Power Project, which is by a company called Alicosoft, and there's Pro Planner, there's Phoenix. There's a few other tools out there that are actually good up and comers for the industry because they're designed with construction in mind. But those are what you need to use. If you're going to create a CPM schedule, you need a CPM scheduling tool. Again, Excel's not one, Visio's not one, hand-drawn on a sheet of paper is not one. These tools are powerful. Use them. We're going to be talking about today. So the second thing you need to do, which quite frequently gets sort of lost. I think it makes a lot of sense to have working sessions with people who are going to be involved, people who know construction, people who are taking on the risk for the job, which is maybe the project executives, the superintendents, the PMs, maybe even some of your early subs, can get together in a room looking at the drawings and starting to think through all the little nuances of how you're going to build this thing. Because generally speaking, your first step, and if there was just one person involved that just popped open a scheduling program and just started going to town on what activities to add and all of that, they're not getting everybody's input, and the more input, the better. So I suggest with every single baseline schedule, you sit in a room, you look at the drawings, you literally think through how are you going to build this? What is the best way to build this job? Soup to nuts, getting going on, the foundations and the earthwork, demolition, whatever that may be. And how, once we get through that, how are we going to structure the trades to build this project effectively? Where are our access points? Where are our constraints? What order are we going to go in? Left to right, top down, however you expect to do that, area to area. That's what needs to be discussed and understood. And then you go map out an organizational structure. So this starts that starts to get your wheels turning a little bit of, okay, in my brain, now I understand how am I going to build this thing. And then you need to take that information and start to come up with an organizational structure. We talked a little bit about organizational structures. They're very important. But yeah, as you can see, you might want to have, a section about construction, some procurement, maybe some startup and testing, maybe some design stuff. There's a lot of different categories that you want to break out into phases. And then once you get into each one of those phases, we want to break it out in sort of the order in which we think things should get built. For instance, there's the site work, there's the structure, there's framing, there's mechanical, electrical. You want to start breaking that out by trades or areas. And then you can start breaking it out into a little bit more detail. But for each one of those areas or trades, you want to understand how do they fluctuate with each other, and what, if I'm thinking about this job and the way in which I'm going to build it, how do I bucket activities into different groupings that make sense to me? And the whole reason we want to do that is because if you don't have those organizational structures, the schedule becomes confusing. Here's a schedule that had no organizational structure. Actually, it did, but it wasn't turned on. It's not speaking to me. I can't look at that. I can't just look at that and know exactly what's going on in what order, near term and long term, even over the next 2 weeks, 3 weeks, or even 2 months. Till I put an activity code structure in there or a WBS structure, I can start to view this thing the way I was thinking about it in my head over the calendar in specific order, where I don't just look at a hodgepodge of activities that are bouncing all over the place today. I have some order and structure that I can envision today. What activities need to get done in what order in the near term? How does that look in the long term? That really starts to give me the ability to, view and explain. Not everybody can just look at a scheduling program. A lot of times scheduling programs, they're utilized to go explain to somebody how to approach something, whether it's the subcontractors, whether it's the owner. You want to be able to have something that can speak, and without that organizational structure, it doesn't necessarily speak to you or anybody else around. And that's why I would say thinking through that organizational structure is very important early on, and it really does need to mirror what you were thinking about as you were planning that out of that job. After that, you're ready. You are ready to start listing activities. So now this is where the fun part comes in. Breaking up into each one of those organizational components, you want to start thinking what activities represent this organizational component. So for each one, you can start listing out the activities. In the program, as you list them out, they'll get an activity ID, which is great, but you want to understand what is this activity, and you usually want to assign it to that WBS structure or that organizational component, and you give it a name and you give it a duration as you go. You can write these down. A lot of times people like to write this down in an Excel spreadsheet and then transfer it over, which I don't think is a bad idea. Or sometimes they like to just build it into the Microsoft or Primavera product, or Asta, or other ones. And just build it as they go. But it's important to think about duration. It's important to think about the activity and the level of detail. Again, we do not want things more than 20 days, especially on the construction side of things. And we definitely need to be very cognizant of long duration activities. Once we do that, we have to apply the necessary relationships. So just so everybody understands, there's 4 different types of relationships. They're stated as finish to start, which is a relationship that says between one activity and another, you can't start that second activity until you finish the first. So it's saying finish to start means finish the first activity before you start the second activity. There's also a start to start tie. Oh, and by the way, that finish to start tie is one of those things that generally is you don't want it to have anything else to start until you're done with one area. That's true with crew logic. If you have a crew moving from one area to the next, it's usually a finish to start because you're waiting for that area to be done so the crew can move. But it's also very common for hard logic. Like I literally cannot start my roof until my structure is up. Or I can't really start pouring concrete on level 1 until I've put my rebar and forming in. I just can't do it. And I can't start level 2 until I'm done with level 1. Those are finish to start constraints, or sorry, logic ties. Start to start is another one. This is a tie that denotes that a successor can start after a predecessor starts. For instance, if you want to start painting the wall before they've actually put up the wall across a big room, you don't want to wait until all the walls are in to start painting on a given floor. You can say, I'm not going to wait until the end of all that stuff to start painting, because if I did that, this project would take too long. If I can paint before they're completely done with something, then I'm going to start that a couple days after the previous activity, the installation of the walls had started. Same thing with like mechanical and electrical. You don't need to wait until the entire HVAC system's been placed in on a floor to start doing electrical conduit and wiring. So you would use what's called a start to start tie with some lag, which we'll talk about in a sec. Finish to finish tie, same thing. It's like you can do these two things simultaneously, but you can't finish it until the previous activity is finished. So there's a finish to finish tie. Same thing applies with like painting and the drywall. Like if you want to start painting before the drywall is completely installed, you can, but you're not going to finish painting before that drywall is complete. You just can't paint a wall that's not there. So you would have the ability to put in a logic tie that says finish to finish. And all you're doing here is telling the program how you're going to build this thing. It doesn't know it doesn't actually know you're painting, and it doesn't know you're putting a drywall. Those are words to it. What it knows is you have an activity that's happening and another activity that can't finish before that. So a lot of times people forget these things. They assume the program can think. It can't. And then there's a start to finish tie, which is a little confusing. It's basically saying I can't start my predecessor until the successor is finished. If you notice, finish to start, finish represents the predecessor, start represents the successor. Same thing on start to start and finish to finish. But I can't start my predecessor until I finish my successor. It's crossed out because most schedules will tell you that that's it's a bad practice. There's a few reasons you might want to do this practice, and I know a couple, and I'm happy to discuss that. But most of all schedulers believe that this is not the type of tie you want at all in your schedule. And then there's a component called lag. Lag is essentially a number of days that you assign of additional time. Looks like somebody says they've lost audio. Is that true for everybody? No? Okay, looks like it can be heard. So lag is a time component, and I'll talk to you about that visually right here. But by the way, to me, understanding and making sure the logic is as accurate as possible and as complete as possible is probably the most important thing you can do in any and all scheduling. You have to think through it thoroughly. You have to tell the program all the little things that you're thinking about in terms of order. You can't forget these things. Like, for instance, if you don't tell the program that you finish painting before the wall is up, like I said, it doesn't know construction. It doesn't understand how you think. If you say that an activity is not tied that way, but they really are, it's not going to correct you. So you have to think through all of these things. And I know it sounds complex, but again, in going with what we talked about last week, it's worth it. I mean, our goal is managers of projects and overseers of projects, people involved in construction, we want things to get done on time, on budget. We've got this amazing tool that can help. But if you're not putting in all the detail that you need to make it as effective as possible, you're sort of putting yourself in a bad position. And to me, thinking through the logic thoroughly, double and triple checking everything, and ensuring that you believe that this is as complete as possible is very important. So finish to start, I'll show you visually. First, finish to start, lag 0. This is basically saying when activity A gets done, immediately after B can start. When lag is 2, this basically says once A is done, I'm going to wait 2 days to start B. And one of those, a common thing for that is like the curing of concrete. Like you can pour the concrete, you can put in the rebar and the forming, but you're going to have to wait a couple days before you do anything moving on to the next floor because it's got to cure. Usually that's more like 3 or 4 days, but nonetheless, there is a mechanism for you to tell the program that you're going to wait a couple days to start the next thing. And then there's negative lag that basically says, well, once I'm done, about 2 days before I finish this activity, I want to start the next activity. And that may be how you're going to build something. So you can put in a finish to start tie with negative lag, and that's acceptable to a point. It's not always considered a best practice if you do it excessively, but we'll get into that in a little bit. So those are your 3 examples there. Start to start, similarly, lag 0, that's got the time component is nothing. That means you can start an activity the same exact day you start the predecessor, which, I see a lot of times that they're starting fire sprinklers as well as plumbing on the same day. Sometimes they start mechanical and electrical on the same day. Sometimes they stagger that, but generally it's up to you to decide if there's 2 activities that you think are going to start together. You can use a start to start with lag 0. Start to start with lag 2 basically says, well, once I get activity A started, I'm going to then work on activity B 2 days later. That means I'm going to give them a little bit of a head start, and then I'm going to have somebody follow in suit. And that's really how you would do that. You would say a start to start tie with lag 2. Negative lag, not recommended here because you might as well just flip the logic. Call activity B the predecessor and activity A the successor. So I don't think it's recommended to have a negative lag on a start to start tie. It just doesn't make sense. It's sort of backwards. Getting into finish to start, same thing. Finish to finish lag 0 is like we can finish this thing on the same day. Like I can start putting up my drywall. I'm going to get going on my painting, at some point in time, when I'm about halfway done with my drywall. But since these painters are going to move so much quicker than these drywallers, we're going to try to nail it on the same day. That's one way to look at it. This isn't actually the finish to finish lag 2. I'm sorry. Finish to finish lag 2 would actually show it going to right here. And it would pull this activity to right there. So basically say, when this activity gets done, I'm going to finish this activity 2 days later. My apologies that this graphic isn't accurate. I should have picked up on that, but I will, when we send these out, we will correct this. And then there's finish to finish lag negative 2. This thing, it doesn't really, similar to the lag negative 2 with start to start, it doesn't necessarily hold water here. You might as well just merge these 2 things together. So it's not a recommended practice for finish to finish is putting negative lag, because you might just want to flip them over and make it positive lag. Once you get through that, so now we've listed we've created our organizational structure, our WBS. We've listed, in each one of those components, we've listed our activities. We've gone through it, and we've assigned relationships and logic for all the activities in the plan. We've thought through for every activity what needs to come before this, what needs to come after it. Are these start to starts, finish to finishes, finish to start ties? Is there lag? We've thought through all of that. We're getting very close to a completion to a baseline schedule, but then we got to start stuff. For instance, calendars, right? Are all these activities 5-day-a-week calendars? Are they working 6-day-a-week calendars? Are they working 4-day-a-week calendars? Do these calendars incorporate weather? If you're not incorporating weather and weather's going to happen and there's going to be 4 days of rain on average in, say, June. We want to mark some of that stuff up. So we've got to think about that. And, a lot of times there's situations where there's shutdowns, right? Like I've seen airport jobs, road jobs, even seen a project that was going on during the Masters, and they had to cut out that whole week during the Masters so that they couldn't work because it was in Augusta. So calendars are one thing you want to think about. There's other things you want to think about, like for instance, a constrained start date for something. Like you talk to the structural steel guy and they say that they can't start working until April 1st because they don't work in the winters or whatever it may be. Also concrete, you might not be able to get started going on concrete until the winter's over. You can use a constraint. You can apply that to a calendar. And then there's also crew. There's logic about crews, and we'll get into that. So after you look at that, after you go through that whole entire process of listing all the activities, assigning all the logic, setting up that org structure, you're not done. You need to start thinking a little bit more broad about calendars and crew flow and that sort of thing. Constraint dates. So that starts to get into, what are some things that are surrounding us that we need to be cognizant of that could affect this project and could affect specific activities at certain points in time. And that's where we start to, apply the last bit of thinking to this plan. Somebody asked the question, what is a WBS? WBS is work breakdown structure. It's similar. It's just an organizational structure that you can utilize in Microsoft Project or Primavera. It's basically breaking your project up into parts and pieces based on trades and assigning it a coding structure so that you can organize in that manner. So real quick, we talk about hard logic, we talk about crew logic. These are very important concepts. And I apologize, I know this is a lot to digest. We will be sending this out. Trying to get this amount of information done in an hour can be tough, but I will get you through it. But hard logic and crew logic, two different things, which crew logic is probably the lesser known of the two. If you think about hard logic, to me, that hard logic is the thing that makes it, you're basically saying what's possible. So these gray bars, right? I can't go to structure on floor 2 until I'm done. I physically can't do it. And I'm not going to start MEP if there's no structure on level 1 either. And there's no point in starting framing until my MEP is done, because that MEP needs to be up and hanging and before I get my framing for my drywall. And I'm not going to start drywall until all that framing is done. Those are hard logic ties. They're basically saying that, these are things that you just can't do. Crew logic's a little different. For instance, you see before this, you say that we've got structure, then MEP, then framing, and then below I've got structure, then MEP and framing. You see that these activities basically say I'm going to go MEP floor 1 to MEP floor 2, but you're not telling the schedule that. The scheduling program sees that this MEP on level 1 is dependent on structure. This MEP on level 2 is dependent on structure, but it's not telling you that, wait a second, there's also a crew that needs to go from this to that, because if you don't tell it that, there's problems, and I'll show you what those problems may be. So that's what crew logic is. You also want to put into the program that you're scheduling that there is actually a crew restraint going here as well. And why is that important? I'll show you. So if you don't have crew logic, and say that you got your structure done on floor 1 and you started MEP and that got done on floor 1 on time, and then you got your structure done on floor 2, and then you started framing, that didn't get done on time. It took longer. Well, look, the program doesn't know that you don't have, that there's only one crew because you didn't put that crew logic in, and that shows you that the program thinks that because you didn't put that crew logic in, that you could magically bring a second crew in if needed. And we all know that that's never the case. So that's a recipe for trade stacking. If anybody's ever heard of trade stacking, it's when all of a sudden so many areas got delayed that all these trades, multiple crews to keep up with the plan. The way in which that happens is by forgetting crew logic, and then all of a sudden you're in this compressed state because the scheduling program didn't know to push out that drywall activity. So if I put that crew logic in there, it would tell me something else, and I'll show you what that is. So say that that framing activity is taking too long and it's pushing out that drywall activity. Well, guess what? It's also pushing out this framing activity and then that drywall activity. So basically what it's saying is, oh, well, this is taking too long, so now we're delayed. So if you go back to this situation here, the end date didn't move out. The critical path wasn't impacted. All the program wanted to do was just say that you need to get another crew going, but maybe you couldn't get that crew and maybe you knew that from the get-go. If you put that crew logic in, you will see that impact. That end date will kick out. The critical path will shift as well. And that's what we want to see. I know we talk about it all the time that nobody wants to talk about delays. The only rule in Fight Club is not to talk about delays, but you know what? We got to talk about delays. If we don't talk about delays, we end up, guess what? Delayed. So you want to know there's delays are happening, when they're happening, because right there and then, if I know there's a delay, if I know that critical path shift, I know I need to go get another crew if I want to recover. If you don't see that, and this could slip through the cracks, you're not getting that other crew. And that, to me, is one of the biggest problems in construction that we've seen. So with crew logic, impacts are clear. Without crew logic, things get stacked. Delays not seen. So those are the two types of logic types. You always need to contemplate what is the order of which things are possible. That's our hard logic. And then what are the order of crews moving through the area, and put that in there so that your schedule is what I call reactive to delay. And I'll trust me when I tell you, that's the time where when you see that delay in that update because of that crew logic, that gives you the option at that point in time to correct. If you don't see it happening and you just update the schedule and the end date didn't move, you assume everything's fine. And you're people aren't always double checking, well, are we getting trade stacked or what? No, they're looking at, did the critical path change? Did the end date move? Oh, no? Okay, we're doing everything right. So that's why I mentioned to everybody that if you want to really, really up your game in scheduling, contemplate crew logic big time. Once you do that, once you get through all of that, you can't assume it's done either. We talked about that. There's plan, schedule, now it's optimized. So after you do all these things, now it's time to stand back, take a look at the overall schedule. You want to make sure that it's in alignment with the contract, not 3 months shorter, not 5 months longer, that the critical path seems to make sense the way that you would envision a critical path being. And if it's not, you've got to start thinking through, well, we've got to do things differently. For instance, if you did what you did and you put all that logic in there and you put all your crew logic in there and you put all your durations in, and all of a sudden it's 5 months longer than what your contractual duration is, well, you've got to get it into that contractual duration, which means you've got to start figuring out areas where you can double up on crews or, shorten durations based on having more people. And that starts to get you thinking about the project in a much, much deeper way, and also getting in alignment with your plan. Same thing. If you look on the other end of the spectrum and you've got 2 years to get a job done, but your schedule says you'll get it done in 16 months, well, now you've got 8 months of float, and we don't want that either. That's a little bit misleading. We have to double check and make sure that we didn't miss something, we didn't miss logic, whatever you name it. It's always good to then look at the schedule, get a couple different sets of eyes on it, make sure that it's in alignment, make sure that it's past the gut check on the criticality and the near criticality activities, make sure that we didn't forget anything completely. That's what this optimize is all about. So let's get on to the meat and probably the most important piece of this discussion. It's a little bit more, I guess, intermediate level, but we talked about schedule quality. There's this thing called the DCMA, Defense Contractors Management Association, which is the gold standard in gauging schedule quality. It's a 14-point check that looks at things like the frequency of missing logic, the existence of negative lag. Remember, we talked about negative lag sometimes not being used. It also said positive lags not always acceptable at a certain level. Like, you can't have every activity start to start and every activity finish to finish. It's better to have more activities finish to start, because that sets you up for success to have one area done before the next crew comes in. There's also things like a lot of high float that you look at and a lot of high duration. But these are the 14 points that we're looking for, with 3 very important driving indicators of quality. Missing logic, too many constraints, and too many high durations would be the 3 most important areas to focus to start. They would impact your quality the most, and they are actually drivers of all the other issues. For instance, missing logic and maybe constraints is going to drive your float. You know, high duration activities is another issue that would alter your critical path. And if you had a lot of high duration activities, you'd probably have a lot more start to start and finish to finish ties. You know, so all these things are generally interrelated, and there are reasons why they're risks. Missing logic basically makes your schedule unreactive and misleading. Too many constraints basically says that you decided to put in start dates based on what you thought it would be instead of letting the program decide through your logical ties. High duration is a risk because it ultimately makes the activities much more difficult to status accurately, which could then again put the critical path at risk. And all of these 3 indicators are pretty much what drive the others. So if and when schedule quality is a factor, these are the first 3 things I look for. They are the root of all other quality issues. And if you want to get more information, I would Google DCMA and schedule and learn a little bit about this 14-point check. And we're happy to give you our information as well. We've got blogs, we have white papers on all of this kind of stuff. So if you're interested in any of that, let us know. So the schedule quality cheat sheet, the DCMA to me, and I'll be quick on this, it's a pass-fail type situation. They say if you have more than 5% of your activities with missing logic, you failed. Some cases, some people believe 1 missing logic tie is a fail. You have more than 5% of your schedule has constraints, you fail. If more than 5 or 10% of your schedule is start to start or finish to finish, it's a fail. I don't agree with that. I think projects in construction can vary. There's linear projects, there's horizontal projects, there's vertical projects, there's horizontal and vertical projects, there's mega projects, there's little projects. We actually created a grading rubric that you can adjust actually these 14 items as well as about another 20 more that would help you gauge best practices in your schedule, but you can decide what those thresholds are. Our out-of-the-box schedule quality cheat sheet is this. It seems to be pretty much in alignment if you were to come up with one model for all projects, which I personally don't think that you should do, but we as a company have one model as a starting model for most, we'll call them building construction or office construction or multifamily construction jobs. What we want to see here is I like to look at the ratio of logic to activities, like how many logic ties do we have as compared to how many activities. Greater than 1.5 starts to tell me that on average, every activity has more than one and potentially up to 2 successors, which would tell me that we've got our hard logic and our crew logic tie in there. When that number starts going more 1-to-1, if there's equal as many activities as there are logic ties, that means that we're not contemplating both hard logic and crew logic. So that's why I like to look at that one. And once you're over that 1.5 range, it starts to show evidence of crew logic. But that doesn't mean every activity has crew logic. It just means, I'm not sure that's a concern right now, and I'll talk a little bit about when it becomes a concern. Next is the number of finish to start ties, the number of start to start ties, the number of finish to finish ties, and the number of start to finish ties. Generally speaking, 0% should be start to finish. I believe that, about 80 on average, about 80% should be finish to start, which includes both hard logic and crew logic. And about maybe 10% of each finish to start and start to start is a good indicator. Once you start to get about 15% of your logic ties are start to start and finish to finish, that might become a problem. It might say that you have too many high duration activities. It might say that your schedule is getting too compressed. And so when I say lacking detail, that means that we've got more long duration activities. For instance, if we're going to put up, all the walls on a given floor, or, all the interior trades is one long band. Well, you're not going to wait till everything on the entire floor is done to move to the next floor. So you would use more start to start and finish to finish if you had more activities with high durations. So this is the gauge, and generally, we want, if you're putting in enough crew logic, if you're, cognizant of the level of detail, you should have more finish to starts and less start to start and finish to finish activities. And this is what we would generally deem the sweet spot, somewhere in here. Now, this is my opinion, and this is on a quasi horizontal vertical building type job. This can change if you had a more linear job. There'd be a lot more finish to start ties than there would be any start to start and finish to finish ties. And then there's if you have way less detail or way more detail, you'd have a lot more finish to start ties. Missing logic, again, the rule of thumb is every activity except for the first and the last one should have a predecessor and successor. Now, we know there are some extenuating circumstances, but we really want to do our best to make sure that every single activity has a predecessor and a successor except for the first one and the last one. Open ends create miscalcs on criticality. So it's always good to double check if there is missing logic that's okay. That it's not altering the critical path, that we didn't forget something. It creates an unreactive schedule because if nothing's following an activity and there actually is one that's supposed to follow it, well, that program is not going to know it. And if this activity is late and there's a successor that hasn't been tied to it, well, the program's not going to push that successor out because you forgot the logic tie. So that's why it's also important. Same thing with, negative lag and positive lag. Those are usually tied to situations where you have start to start and finish to finish ties. So if there's excessive amounts of that and there's excessive amount to start and finish to finish ties, then we start to see a schedule that's, again, lacking detail, potentially overly compressed. This isn't all about the baseline. This is also about future activities on a project that's already being status. So, the more activities that are stacked, that's done through these start to start and finish to finish ties, there's a chance that your schedule's getting overly compressed due to delays. And that's a whole nother can of worms that we'll talk about in the updating process when people, update with their making changes to stack the trades because delays are happening and they're not actually going out there and making those changes in the field, and you get to this overly compressed state and you're not actually studying how compressed the schedule is getting. That starts to become misleading as well. And it's not good. It's not good for the contractor. It's not good for the owner to believe in a date that's impossible due to a schedule that's been crashed or overly compressed. And the signal for that would be more start to start, more finish to finish. Start the percentage of these going up over time, which is things that we can track in SmartPM. Too many constraints, again, without logic, the schedule's unreactive. If you're sitting there, guessing dates of activities to start, number one, that's a problem because most activities should have something driving that. And if you haven't tied that in, you're generally picking a date out of the air and hoping that it happens. And if you never change that, if delays happen, but that would normally impact that, but you haven't tied anything to it, you've picked the date, that's problem number one. And you've done that all over your schedule. That's a huge problem. It's going to show a critical path that's not true. And number two, there's finish constraints that you need to worry about. A lot of times people will put finish constraints in a schedule so that they can gauge delay, but they do it on multiple activities. And when delays happen, float goes to negative and more activities become red, so you lose sight of the critical path. And those are things that you need to be cognizant of. High float basically tells us that there's either missing logic or missing crew logic. If there's high float is deemed by greater than 2 months, 33, I see so many schedules that are like 70, 80% of their activities have more than 2 months of float. It's basically saying 70 to 80% of your job can be delayed by 2 months. 70% of the activities in your job can be delayed at least 2 months and you'll still get done on time. No, we don't want that. We want to have a very reactive schedule with not a ton of room for delay across the board. Construction was like that. I wish 70% of the activities could be delayed without actually impacting the end date, but it's just not like that. And if you create a schedule that says it is, you're really shooting yourself in the foot. This number, if you have less than 20% roundabout, that's a good sign, because you know at any given point in time, if delays happen, you'll be notified immediately and you can adjust. If you don't see that and your schedule's poorly built with missing crew logic or missing logic with a ton of float that basically says we can screw this thing up left and right and everything will be fine, that's just not construction, but yet most schedules say it is. And that's what we really need to get, in our heads. High duration, again, I've talked a little bit about that, and I know I've got about 5 more minutes, but that shows that a schedule lacks detail, can be overly compressed. It will likely have a critical path that's inaccurate, and I'll show you examples here. So, give you a quick example. We might go a little bit over time, guys. I hope that you're able to stick around. If not, again, we have a video. But here's a schedule. I want to show you a schedule that has problems. It looks good. I mean, it looks like there's great order from floor to floor to floor, but I noticed something here. Again, this is like when I'm in my optimized state. Like, why is everything so critical? Why is the pre-construction critical? And then why is the foundations critical? And why is the underpinning critical? And then why is the structure critical? And then why are the enclosure critical? And then how come my interiors are critical across so many floors and my site work's critical too? Well, this shows me a schedule that's got too much critical path. This is probably, if we go back to our deck here, this is probably definitely way over 30% of the schedule is critical. And that's a problem. It's going to get called by the quality gauge in SmartPM. I'm going to look at it. I'm going to go, okay, well, what do I see? Oh, I see negative float. That means I've got finish constraints, and maybe I want to remove those finish constraints. So let's go ahead and do that. I remove those finish constraints, and look, we now have a very, very interesting critical path that goes through the structure into the enclosure and then ultimately on the top floor and then close out. So now I've got very few activities on the critical path. By making that one change to those finish constraints, now I see a schedule that has very few, but one of the signs is, if I see an activity that, a critical path that's this basic, like basically saying the top floor is the most critical floor, and every room, every other floor there has room for delay, and in some cases a lot. We can see right here, we got 114 days, which extends to the end of the 19th floor. And as we go down, they just keep getting, it gets lower and lower and lower. That is my indicator that we forgot crew logic. Remember the crew logic concept? If we forgot crew logic, then our critical path again is basically saying, if push comes to shove, we can get 19 floors of 19 trades done all at the same time across the board. And we just know that can't happen. So I go put my crew logic in, and guess what? There's a critical path that makes sense. Yes, it's in the structure for a while. Yes, it gets into my enclosures. Oh, wow. Then it gets into my drywall, and it stays in my drywall for a little bit, and then it gets into some of my MEPs. Or maybe vice versa, my MEPs first and then into my drywall. These crews, if any impacts happen, it's going to push that end date out because they are moving floor to floor. That is a critical path that makes sense in a building. So that's why I talk about these concepts. If you don't follow these things, you're going to have critical path and float values that are just wrong and misleading, and you end up in trouble. Another example of long duration activities, elevators. I see it all the time. Elevators take the critical path and then it goes into like testing and commissioning. So this big building's going up, but if you get the superstructure done and the elevators done on time, and then you get, move that man hoist and put those windows in, and then you do your startup and commissioning on time, you're good. Well, that's just not going to happen. So if we add more detail to elevators, right, we break it up a little bit, we'll see here again, our critical path goes through the structure, into the envelope, into some of the floors for extended periods of time. That starts to feel like a more accurate, useful, critical path. It's not just in one area of the job. It's where the most crews will be moving through the job, where the most work's supposed to happen. And that is why we do these things. Again, start constraint, right? Somebody picked thin air and said, oh, well, we're going to start rough-ins on or building fit, whatever this activity is, sometime next year or sometime in like September. Well, guess what? Nothing's driving that. So it creates this critical path and it tells me, well, we've got float on all these other things. But once I remove that finish constraint, guess what? I see a real critical path that I can manage to. So that, again, that's why these constraints are an issue. So I think we're getting done on time. We're going to have a couple more minutes, but I hope those visuals explain to you why there's a method to our madness here, why schedule quality is a thing. I hope that the process that we talked to you about was useful to not just whip through it, to think through it with others. Start to map out a structure that aligns with what you're thinking in your head. Start to put those activities in. Start to estimate durations that incorporate a little bit of risks. Then throw in your logic and think about that thoroughly. And then you double check. You look at it. You make sure that it seems right, that it's aligned with your contract. But here are your top 5 things that you should do. If you do these 5 things, I mean, every single time as you build out a schedule, you'd probably be better than 90% of the schedulers out there. Rule number one, every activity needs at least one predecessor and a successor, except for the start and the completion. Remember that. Always remember that. Any activity that doesn't have a successor, make sure you find it a successor. Unless you just know there's nothing that can come after it and it could get done on the last day of the job. But I don't think that's very common. Constraints can be utilized. There are circumstances to utilize them, but don't utilize them too much. The start constraints. Don't pick out a ton of days to start an activity that you think is going to happen. Let the program's logic do the work. And I'm a huge fan of no finish constraints. People like finish constraints because it tells you how late you are. I can do the math, and actually SmartPM can do the math. The problem is when you have too many finish constraints, it hijacks the critical path and the whole thing turns red and you lose everything. You do not know what's truly driving the end date of the job if you have too many finish constraints. No construction activity should have longer than a 20-day duration. Should say construction activity there. You know, your fabrication, your procurement activities, sometimes people like to put them in here. I'm kind of on the fence with that one, but nonetheless, they can be longer. But generally speaking, in construction, let's keep it to 20 days or less, 5 days or more. You can have some 1 day, 2 day, 3 day activities. Great. Don't be in a habit of doing that all over because it just creates a academic exercise of too many activities and a structural nightmare for the supers and the PMs to follow. When you think about all the trades, all your major trades, all the trades that keep you up at night, your concrete, your MEP, your structure, your enclosure, your drywall, your millwork, you know, your punch list, your flooring, your ceilings, all the ones that, you know, are critical or could become critical at some point in time, the ones that if people didn't show up, you would be annoyed if they didn't. You put in that crew logic. And then the last thing to remember is after you look at it, you know, use your gut. You can use your gut. This isn't all science. There's also a lot of experience that needs to be here. So you got to look at that schedule and you got to think through what it's telling you. And if it's telling you something that doesn't align with what you think, then you got to go back and double check a few things. So I always like to put a good gut check in there. Finally, next week, I'm sorry, we're a couple minutes over. We'll be talking about updating best practices. Why do we update? There's a whole reason to do it. Some people, I think most people understand, but usually it's in the contract, but that's not why we do it. We do it because construction changes, and we need to update that schedule to know where we stand today. And if anything changed along the way, or if the critical path shifted, this is a dynamic thing. It's a living, breathing thing. We need to know based on the progress to date what that means for the future of the job. We'll talk a little bit about a process that works, what the best practices are, the do's and don'ts. And then we'll talk about how do you review and update? You know, what do you look for? You know, like I said, compression's a problem. Delays happen. People make changes. There's a process for reviewing those things, and there's some risks associated with it, so we'll go over that as well. There you go. Schedule updating best practices. There are a series, there's a bunch of questions, and I will, we will not have time to answer them right now, but we will answer them, and they will be submitted to you after this meeting. The question will be answered, and we'll go from there. Thank you so much for joining us today. Enjoy the rest of your day.